Hi calculus students. These video notes are on the derivatives of the functions ln x and e to the x. So first, just a quick reminder of the relationship between these two functions. E to the x is an exponential function that's commonly used in real-world applications. And remember, e is just a number. E is like 2.71 something. It keeps going. So this is a number raised to the x power. And then if we have another function y equals ln x, the meaning of ln x is the natural log of x. It's the same thing as saying log base e of x. So essentially, e to the x and ln x are inverse functions of one another, which means that if you compose them, it gives you back x, or 1. So the idea, just like a quick identity, is that like if you have e to the ln x, that's the same thing as just x. And if you do ln of e to the x, that's also just the same thing as x. That's just something that's kind of useful to keep in mind, because if you see this structure, it might save you some time if you realize that's equivalent to x, if you realize that's equivalent to x. But we're not going to be doing so much with those relationships. I just wanted to kind of remind you of that moving forward. These are going to be our last two derivative rules that I'm going to have you memorize, but they're not so bad. So I think that you'll be like, oh, this isn't so. I'll be able to kind of just add this to my repertoire and keep using the rules that I already know how to use. So the idea is that the derivative of e to the x is the same exact function, e to the x, and the derivative of ln x is 1 over x. Okay, so you will need to memorize those derivative rules. And the rest of these notes, we're just going to look at some examples of functions that involve e to the x and ln x and see how we can take their derivatives. Okay, so my first example, we're going to start with some natural log problems. So if we have something like y equals x to the 4th times ln x. So the idea is, what is the underlying structure here? I see I have a product. Right, so I know I'm going to need to do the product rule because I see multiplication. So let me set up my u and my v. U is x to the 4th, v is ln x, u prime is 4x to the 3rd, v prime is 1 over x. So when I go to put it all together, I'm going to get y prime is equal to u times v prime, x to the 4th times 1 over x, plus u prime times v, or v times u prime. That's ln x times 4x to the 3rd. This point, I'm thinking about what simplification I can do. So first of all, I see like an x to the 4th divided by an x. That's basically just going to like cancel one x out top and bottom. So I'm going to get an x to the 3rd here. And then the other thing I'm going to do is just kind of like move this out front just so it looks a little bit nicer. So 4x to the 3rd times ln x. The only other thing I could do would be to factor out an x to the 3rd. That's kind of like an optional thing. So if you're looking for ways to simplify, I could factor out that x to the 3rd and I would get 1 plus 4 ln x. Okay, so I would accept either of those two answers. Okay, let's look at another example. So my next example is going to be a chain rule problem. So we know how to do the chain rule now. So if we have ln of t raised to the 5th power, so this is there's an outside function and an inside function. So I need to use the chain rule. So that would be my f is x to the 5th, my g is ln t. Oh, since my variable here is t, I'm going to call this t, just for consistency's sake. So f prime is 5t to the 4th, and g prime is 1 over t. So now I should do, putting it all together, it's got to be plugging this in for this t. I get 5 times ln t to the 4th power times 1 over t. The only real simplification I can do at this point would be I could write this all as one fraction, so I could write it as 5 ln of t to the 4th all over t. Okay, so at this point, I'm just going to give you 2 U-try problems that involve ln x. So, let me slide this up. So the first one is going to be y equals tan of x times ln x. And the second one is going to be y equals ln of x to the 5th. So what I'll say about this one is it is different from the example I just did, but it is related to that example. Okay. So now I'm going to show you a couple, so you can try these problems out and then pause the video, try these problems out, then press play to continue. I'm now going to show you some examples that involve the e to the x function. Example 3 we're going to look at is y equals 2 e to the x. This is really simple. So remember, the derivative of e to the x is e to the x. And here we have e to the x times some constant. So this is the constant multiple rule. So remember, if you have some constant times a function, the derivative of this will be that constant times the derivative of the function, right? So the idea here would be, since the derivative of e to the x is e to the x, the same function, then I would just multiply it by the 2. So the derivative of 2 to the x is the same exact thing, 2e to the x. So let's look at an example where it's a little bit more complex. This is y equals e to the 2x. So here, this is a chain rule problem. Right, where the inside function is this 2x, the outside function is e to the x. So my derivative of e to the x is e to the x, my derivative of 2x is 2, so I'm plugging that 2x in there, so I should get y equals e to the 2x times 2. Y prime equals 2 times e to the 2x. Another way of thinking about the chain rule with e to the x as the outside function is just literally rewriting the exact same function, e to the 2x, and then multiplying it by the derivative of the inside function, which is that 2. Okay, let's look at another one. So this one is y equals e to the x. So this looks kind of crazy, but it's not that much harder than the one we just did. Still a chain rule, where your inside and your outside functions are both e to the x. So this is going to look a little funky, but the idea is the derivative of each of these is still e to the x, right? And then the only thing is I'm taking my g and plugging it in for that x. So it should give me y prime is equal to e to the x times g prime, which is also e to the x. And if I'm thinking about simplifying, I have the same base in both of these of e, so then I could add these exponents and just have one base, which would look like e to the x plus x. And that's just like the most kind of simplified I could make that. I'm going to show you one more example and then give you a couple more u-tries. In this example, this is one where we can use one of those identities I showed you at the beginning. So the idea is if I have the function e to the ln x, I could set this up as a chain rule where e to the x is the outside function and ln x is the inside function. Or if I can recognize that e and ln cancel, this is the same thing as x, then I know right away that y prime is just 1. If I didn't necessarily see that, then the idea is I could have done like a whole chain rule, right? Where I said f is e to the x and g is ln x, f prime is still e to the x, and g prime is 1 over x, in which case I get y prime is e to the ln x times 1 over x. And from there I could see my simplification, and this becomes just x times 1 over x, which is exactly 1. Okay, so the key is for that is just kind of be on the lookout for that situation, or like the situation where you have ln of e to the x, something like that. That's also going to equal x, right? So if you can recognize it, it saves you a little bit of time. So a second set of u-tries, we'll call this u-try C and u-try D. So I'm going to give you y equals e to the x times ln x. And I'm going to give you y equals e to the 2x squared plus 6x. So try those ones out, and we'll be discussing it next time we have class.